Okay, so we've just created our own struct called framePackage, and we put it in its own header file called framePackage.h. Now we can use this in any other class that we would like to use it in order to store one frame's worth of data for a given object. Now we're going to store location, rotation, angular and linear velocity, Boolean saying whether or not this belongs to the player pawn, and the mouse XY value for the player pawn if we're storing that, and then of course delta time for this given frame. So now what I'd like to do is create an actor component that will actually take care of storing the data per frame, and that way any actor that we wish to participate in the time reversal system, well, it can just have that component. So let's go back to the editor and let's go ahead and create ourselves a new C++ class. So I'm going to go ahead and right click and say new C++ class, and right here you'll see actor component. We're going to go ahead and select that and click next. So for this component we can simply call this reverse time component. And if we click create class, then we'll go ahead and allow Unreal Engine to create this new C++ class for us, and it should show up in Visual Studio. Okay, so we've created this actor component, and if you're not familiar with the actor component, it's a special type of component that you can add to an actor, and it's got its own begin play, it's got its own version of the tick function called tick component. So we can use this in order to gather and store data for any actor that owns this component. And we can be doing this on a frame-by-frame basis, and this way we'll get our 15 seconds worth of stored data, and we'll be storing that per frame. So what we'd like to do is we'd like to have some variables on our tick component, and in particular the first thing that I'd like to add is just down here at the bottom. Why don't we add a Boolean called b reversing time, and b reversing time will be false if we're not reversing time and true if we are reversing time. And if we go into reverse time component.cpp, you'll see that we've got our constructor here, and we can set b reversing time equal to false here by default. Now what I'd like to do is set up a way for our reverse time component to set this Boolean depending on input from the character. And so in order to do that, first of all, we're going to need to set up input for the character, and then we're going to need to figure out a way for the character to broadcast a signal so that all reverse time components in the level will trigger their b reverse time Boolean and set that to true. And likewise, when the appropriate signal is sent by the character to set it to false, then we can set it to false as well. So why don't we go back into Unreal Engine and set up the input for this. So let's go to Edit, Project Settings, and we'll go into the Input section, and here we have Action Mappings and Axis Mappings. Now what I'd like to do is whenever let's just choose a button to press for this. I think I'd like to choose the right mouse button. So whenever the right mouse button is clicked down, we can trigger the functionality to reverse time, and then whenever the right mouse button is released, we can trigger the functionality to stop reversing time and resume the data collection process. So these can easily be action mappings because they don't really need to be updated every frame. They can just be one-offs that happen when the button is pressed and when it is released. So let's go ahead and click plus to do a new action mapping, and let's give this a name. So we can call this reversing time. And I better make sure I spell this correctly, reversing time. And here we'll search for right mouse button and select right mouse button. So this sets up the input for reversing time. So we can go ahead and close that out, and now we have that. Now in our C++ project, we're going to go to the reverse character here. That's the character we have set up for this. And we're going to scroll down in reverse character.cpp to the setup player input component function, and you'll see examples of how we can bind functions to these inputs. And we're going to bind a function to the input we just created, which was called reversing time. And so we can just copy these two, and just under it we can paste them, and we can change the first argument, which is the name of that input we set up in Unreal Engine, and we can call this reversing time. We'll do that for both of these. Now there's two because one is for when the right mouse button is pressed, the other one is for when the right mouse button is released. And that's why you've got this enum constant pressed and released here. And then of course you've got the callback function here, and this callback function, it's set up to call the jump function and the character's stop jumping function. But what we can do is create our own function here, and that's going to be to start the time reversal process. So why don't we go ahead and create those functions? So I'm going to do a shortcut here, and that's Control-KO. And that will open up the H file. And if you didn't know, Control-KO, when you're in the H file, will open up the corresponding C++ file, and vice versa, when you're in the C++ file, it'll open up the .h file. So we're going to go ahead and add a function here. And so what we can do is we can go into our protected section here, just above setup player input component, and we can create a new function. We can make this void, and we can say start reversing time, like so. And likewise, we can make one called void stop reversing time, like so. So we've declared these functions, and we can go ahead and define them. If you click on one of these undefined functions, you'll get the little lamp symbol, which you can just click on and click Create Definition, and that will automatically create a definition here for us. So we have Start Reversing Time, and then we can go ahead and create a definition for Stop Reversing Time, and that will go ahead and take care of creating those definitions for us. So what exactly do we want to do when Start Reversing Time and Stop Reversing Time get called? Okay, so we have definitions for these, and if we go back to setup player input component, we'll see that for reversing time we need to call those functions. So what we can do is call start reversing time for the pressed condition. So we'll do that, and this isn't an a character function, it's a reverse character function. We'll go ahead and fix that for both of these. And then of course stop reversing time will be called when released. So we know this function will be called when we press and release the right mouse button, but what exactly are we going to do in these functions? Well, what we want to do is we want to broadcast a sort of signal that all reverse time components can respond to, and to do that we can easily achieve that effect with a delegate. So specifically a multicast delegate. So what we're going to do is go ahead and declare one of those. So what we can do is go all the way up to, we can go back to reverse character all the way up to the top, and just above the class declaration here we can do the delegate declaration. So it's a macro, and it's declare dynamic multicast delegate. And we'd like this to have one parameter, so this will be the one param version. And if you're not familiar with this, we're creating a delegate. This is a specific type that will exist on the reverse character class, And it's something that other classes can bind functions to. So whenever we broadcast using this delegate, then those functions will respond to our broadcast. And we'll see exactly how this works. So let's go ahead and type the delegate name, the delegate type name, and we're going to call this F reverse time delegate. It's got to be prefixed with an F. And then what's next comes the type for our one parameter, right? We're declaring one specifically that takes one parameter. And then after that, we declare the name of the parameter. So we're going to call this B reverse time. And so this declares the delegate type. But now we need to actually declare a variable of this type. So what we can do is we can choose where to put it, and I'm going to go ahead and scroll down and find where we have our variables. We've got looks like we've got a public section all the way down at the bottom. So I'd like to go ahead and create our own public section below that. And I'm going to save this for, or reserve this for reversing time. So down here, we're going to put the delegate. So it's an F reverse time delegate. And I'm going to call it reverse time delegate. And so since we have this reverse time delegate, what we're going to do is we're going to broadcast whenever basically we click the right mouse button. We're going to broadcast this delegate. And so in order to do that, we can simply go to our reverse time and start and stop reverse time functions. If I go ahead and just go to those definitions, the start reverse time definition, it's taken me to start reversing time. And what we can do here is we can broadcast the delegate. So we have our reverse time delegate, and it's got something called broadcast. And because this delegate takes one parameter, this is where we pass in that parameter. So for start reversing time, we're going to pass in true. And for stop reversing time, we're going to broadcast passing in false. So thus far, this doesn't do anything because we haven't done any binding. We haven't bound any functions to our delegate. That's to be done in other classes. And specifically, we're going to do it in the reverse time component. Once we do bind a function to that, then those functions will be called whenever broadcast gets called. So let's go ahead and bind some functions to this. So let's go back to reverse time component and let's go into begin play. And so in begin play, what we want to do is we want to get the character, and we can do that with a get player pawn function, which is a Kismet math library, or a gameplay statics function, which is in Kismet/gameplay statics. So let's include Kismet/gameplay statics.h, and in begin play we're going to get the character. And so it's of type reverse character. So in the component we're going to say, well, I guess we actually have to include that character as well. So include a reverse time character .h, and we're going to create a local variable of type a reverse time character. It's a pointer. We're going to call this reverse, or just rev time character. We're going to set it equal to, and we're going to cast to a reverse time character. And what are we going to cast? We're going to call a uGameplay statics function called getPlayerPawn. And getPlayerPawn takes the world, so we're going to call it getWorld and pass that in. And then an index, we're going to give it the index of player 0. So this gets us the player pawn. So IntelliSense is taking a while to catch up. but once it catches up, this shouldn't be red anymore. So we have our reverse time character, and what we're going to do for our reverse time character is we're going to actually access reverse time delegate, and on reverse time delegate we're going to call add dynamic. Add dynamic takes a user object, that's going to be this, and then it takes the function. And the function is in the form of an address of a function. It's basically like a function pointer. So we need the address of operator. And then we need to pass in a function. So reverse time component doesn't really have a function that we can pass in yet. So what we need to do is create one. So for reverse time component, let's go ahead and create a function. We can put it in the protected section. It's going to be void, and let's say set reversing time. And I'm noticing now that I made this bool and I spelled it wrong. It should be reversing time, so I'm missing an S there. So we might have to check for that here. It looks like I spelled it correctly here, so that's good. But we created this function, set reversing time, and it's going to take a Boolean. So we're going to call it in reversing time. And what this does is it's going to set our Boolean reversing time. So why don't we go ahead and implement that in reverse time component. So we'll go ahead and give this a function body, and we'll simply set b reversing time equal to this value here in reversing time. And I think what I'd like to do is say if in reversing time, then we can go ahead and do a UE log. We'll do this log temp warning text, and we'll just simply say reversing time. And then else, we'll say stop reversing time. So this way we know if the delegate works. So as soon as we right-click with our character, the character will call the broadcast function. It will call its start reversing time function, which will call broadcast. Once that happens, if our reverse time component has successfully bound a function to that delegate, then the function that is bound to the delegate will be called. And because this delegate is one param and that's of type Boolean, then it will be passed the Boolean. And we can go back to reverse character.cpp, and you'll see up here in reversing time, we call start reversing time and stop reversing time when the right button is pressed. Then in those functions, we call broadcast, passing in the value of true. And so any functions bound to this must take a Boolean, and they will receive the true and false values depending on which one of these is called. And then on reverse time component, we have our function bound to this delegate. So right here is where we put the function that we're binding to it. So it's going to be U reverse time component set reversing time. So actually this needs to be there before we can actually compile. Okay, so I made a couple of typos here. This actually should be reverse character, not reverse time character. So here this should be a reverse character here, and also in the cast here as well. And it looks like I forgot that semicolon there. Okay, other than that, we can go ahead and compile this. And it looks like it's working. Okay, so let's go back into the editor and open our output log here. And let's go ahead and hit play. And actually, before we hit play, what we need to do is we need to use our reverse time component. So we're going to need to create a blueprint from this and add it to a class. So I'm going to go ahead and create a blueprints folder here. And in the blueprints folder, I'm going to add a blueprint to the reverse time component. So I'm going to right click on reverse time component. Oh, and it looks like I can't create a blueprint class based on this, and that's because it's not blueprintable. So let's go back into C++, into the reverse time component.h, and up here, up in the U class macro, we're going to add a comma and say blueprintable. That way this component will be able to be made into a blueprint. And before we test this out, one important detail is that any function that we bind to a delegate, we're going to make sure that this is a U function. If we're binding it to a dynamic multicast delegate, we need it to be a U function. So let's go back into reverse time component.h. We'll take our set reversing time function, give it a U function macro, and we'll go ahead and compile this. Okay, so on reverse time component, if we right click, now we can create a blueprint based on this. So I'm going to select the blueprints folder, and we're going to call this reverse time component BP for blueprint, and this gives us the blueprint. So we can close out of that, and in our blueprints folder, why don't we right click and create a blueprint class based on actor, and I'm going to call this reverse time mesh. And so basically this will be for any mesh that we're going to be reversing time with. And so I'm going to double click on this reverse time mesh, and I'm going to add a static mesh component. And for the static mesh component, for now I'm just going to choose shape_cube, and I'd like to make this a little smaller, so let's make it about 0.5 of its original scale. And I'm going to drag static mesh onto the default scene root to make it the root component. And the reason is because if this is going to be simulating physics, then, well, that has to be done on the mesh component itself. And if the mesh component itself is not the root and it's simulating physics, well, then it'll just fall to the ground, while the root component, if it was just a scene component, well, that scene component would stay hovering in the air while the mesh dropped and fell, and so there would be a disparity. And if you want, I can show you that. If I Control Z to bring this back to how it was here, we have our default scene root as the root, and we have our static mesh component. Now in event graph, in event tick, what I'd like to do is drag out both of these components, and I'm going to do a print string. And I'm going to say static mesh location. And I'm going to take the static mesh, and I'm going to get world location. Off of get world location, I'm going to call toString. And this gives us a string. And then from here, I'm going to call print string, passing in the static mesh location. Then after this, I'm going to call print string again, and for this one I'm going to say scene root location. For the scene component, I'm going to do the same thing. I'm just going to copy these here, and instead of static mesh, we're passing in the default scene root, and we're going to print this value in this print string here. And just to make this a little easier, instead of spamming with so many messages, why don't we just print these locations instead without the messages, and for the default scene root, we'll simply print that in red, like so. And if we hit play, now you'll see the default scene root didn't change, but the mesh location did. So that's why if we're going to have a specific actor to participate in time reversal, we're going to just assume that it has a static mesh, and we're going to assume that that static mesh is the root component. We don't really have to assume that. We just need to know that it has a static mesh, And if it does have a static mesh, well then, assuming it's simulating physics, we'll go ahead and check that to true. Then we'll know that we can set its linear and angular velocity. Now in reality, if anything has a reverse time component on it and it doesn't have a mesh, well then there's really no point in reversing time for it, because the mesh is something that is moving around in the world, and that gives the visual of reversing time. So we have a static mesh on our reverse time mesh, and then we're also going to add a reverse time component. We're going to choose the blueprint version. So we have our reverse time component here. So that should be enough for time reversal. We'll hit play, and when I right click, you'll see that we get the reversing time log. When I unclick with the right button, we get the stop reversing time. Okay, so this is basically enough to conclude this video. What we've achieved so far, just to recap, is we've created a reverse time component. In reverse time component, we have a simple Boolean for when we're reversing time. We also have a set reversing time function to set B reversing time. It's a U function because this is the function we're binding to the delegate we made in our reverse character. So in reverse time component.cpp, we get the reverse character by using uGameplayStatic's getPlayerPawn, and we use add dynamic to bind our function to it, and the function we bind is our set reversing time. So whenever this delegate gets broadcast, set reversing time will respond to it. It will receive the Boolean passed in. And in reverse character.h, we declared a dynamic multicast delegate 1 param. We've specified that parameter to be a Boolean. We called it f reverse time delegate. We then created a f reverse time delegate down here, and we also went ahead and created some input response. So if we go to the reverse character.cpp, here is the function, the two functions that we use to respond to the right mouse button click. The right mouse button when pressed, we call the reverse time delegate broadcast function passing in true, and when unclicked, we pass in false for that. So we've basically set up everything to work so that we can have multiple components in the world. So if I go ahead and just duplicate this reverse time blueprint, this reverse time mesh, in the output log, we'll hit play, and we'll see that when I right click, both of them call the function, and when I unright click, both of them call the function. So we can have as many of these in the world as we want, and we can also create as many basically actors as we want that we would like to respond to the delegate. All we need to do is add a reverse time component to them, and it will work. So this concludes this video. In the next, we will go ahead and get into our reverse time component class and actually start adding code for gathering data and reversing time.